Today we're going to present a paper titled Iris Recognition Using Convolutional Neural Network. This work has been done by Yuan Zhang, Junhong Chou, Qian Chao, as well as Marcus Convolutional from the Department of Electrical Engineering, University of Malaysia. So before we go into the main part of the presentation, let's go through the things that we plan to cover today. So at first we're going to give a brief introduction to iris recognition, as well as talk about the objectives and the aims of the study. And secondly, we're going to briefly talk about the literature review on iris recognition. The third part is going to involve the methodology, how the research has been carried out, and lastly, we're going to talk about the results as well as the conclusion. So without further ado, let's get started. So on the background of iris recognition is an advanced technology that's being actively researched for many decades and right now is gaining even wider popularity. Then one of the contributing factors is the rising artificial intelligence that is providing an even greater opportunity for its further popularization. So on the significance on the two main parts of the research, iris recognition and convolutional neural network. So for the case of iris recognition, it's very safe and it's very secure because everybody has very distinct iris shape, and that will bring us to the next point, high performance. If we are able to recognize iris shape of a big population easily with great accuracy, it's going to give us a very good performance because everybody has different iris shape. And on the third point, it also increases the collectability because it's more acceptable for the general public to consent to the collection of iris compared to other biometric data like thumbprint or even a full facial scanning. So with that 3 points, iris recognition has a very high potential in days to come where we will anticipate individuals will have a higher concern for their own privacy and what types of data are being collected. So for the case of convolutional neural network, it's a very mature algorithm in artificial intelligence. It has been widely applied in many problems in computer vision. And one of the main features is it's very flexible and very stable, can be applied to all sorts of data. And of course, last but not least, the inherent automatic feature extraction is also one of the main points, because if you remove the needs for the user to really explicitly define and design what type of features to extract, which on the other hand also eliminate the possibility of introducing unwanted bias into the model itself. So there are the two main objectives of the study. So number one is to demonstrate and to simplify the iris recognition process using convolutional neural network, and also to improve the applicability as well as the acceptability of iris recognition. So with that said, let's move on to the literature review. So the previous iris recognition methods have been revolving two stages. The first one is a preparation, and also the next is going to be the recognition. So the pre-preparation involves pre-processing, changing to grayscale, resizing, removing the eyelid, and also suppressing it, segmented it, and also the lastly extract the feature. So as you can see, it involves multiple steps in a sequential manner. So next, we have a flowchart describing the entire process. So we will start from the input. So we're going to prepare the input data. We're going to extract the feature. Then we're going to check whether there's a match with our existing database. And if let's say that's not found, then we're going to move on to the next entry in the database until we run out of data in the database. Then we won't be able to recognize that particular iris. So let's move on to the methodology. So in the case of this study, we're trying to simplify the workflow of iris recognition by introducing convolutional neural network as the prime feature extractors in our system. So the structure of the convolutional network that we use in this study is a rather simple one. So it involves an input layer and the first convolutional layer followed by a first polling layer. Then we have the second convolution layer, the second polling layer, and followed by a fully connected layer, which is going to take all the features, combine them, and come up with the probability in a multi-class classification manner. So the working principle of convolutional equals something like you have kernels or filters of the convolution layers that's going to sweep across the input. So in this case, a two-dimensional matrix, and sample each point in the input matrix into a convolve output. So the weights of the filters are being trained during the training process, and by using enough data set, we will be able to form the kernel into a very functional, very robust feature extractor that will be able to sample the key features as it sweeps across the input. So when we have the convolve image, we're going to have a 2x2 max pooling. So the function of this max pooling layer is to downsize the convolve output. So since max pooling is being used in this case, as you can see, the upper right 4 cells will be simplified into just the maximum pixels in this group of 4. So in this case, 4 is being sampled rather than 1, 2, or 3. Then once we have this pole output, it will be fed into the fully connected layer. As mentioned just now, the probability will be computed, and we're going to have the class of the iris that the model thinks the input belongs to. So now we move on to the data sets of the study. So we have 800 images that we have gathered in our database. So they are from 20 individuals, including both left and right eyes. So each eye will have 20 images. So each individual will contribute 40 images to the database, making up that 800 images. So we did a simple image pre-processing. We segmentized the main portion of the eye, as you can see from the illustration on the right, and also downsizing it to 28 by 28 just to make it less computation intensive to run the training. So in terms of the convolutional neural network, as mentioned just now, we have the first convolution layer with 6 kernels, 2x2 subsampling max pooling layer. Then we have a second convolution layer with 12 kernels, as well as the similar max pooling layer that will follow it. So during the training phase, we actually trained the model using 700 images that were randomly selected as the training samples. Then for the testing or validation set, we have the remaining 100 being used in this case. We ran into a situation whereby, due to the random sampling nature of splitting the training and the testing set, there are 2 cases, 119 left and also 310 left, they were totally missing in the testing set. So we have to devise a so-called test tool just to accommodate to this special case. So now we will move on to test tool. So as mentioned just now, it was designed to handle the case of 119 and 310 as well as a real-time test model. And the model used is the final model from test 1. And one good thing to know is that for the 2 cases of 119 and 310, the images were additionally sampled and not from the training set, just to avoid the situation whereby we are using training set to test as the testing set. So now we move on to the results for test 1. So as you can see here, this is the results after 500 times of training of 500 epics. We achieved an overall accuracy of 48%. As illustrated by the figure on the right hand side, the blue rings are the expected class and the red marks are the one predicted by the model. As you can see, it's a mix of hit and misses, so there are some very good prediction for some of the classes, but then overall speaking, we only achieved an accuracy of 48% at this point. So it's mainly due to insufficient training times. So we proceeded with even more training to 2000 epics. So this time we actually achieved an overall accuracy of 99%. And most of the marks actually land perfectly on their respective blue rings. Out of the 38 classes, excluding the 2 special cases we mentioned just now, we actually achieved a 100 accuracy for 37 of them. There's just one case, 406 left, that is having an accuracy of 75%. So overall speaking, very good accuracy for the general population of the classes. So let's take a look at how the improvement of the accuracy is like. So as you can see, during the early stage of the training, the increment in accuracy is actually very slow. So at around 500 epochs, we have around 48%. Then after that, we slowly increase. Then we plateau off at around 2000. That's where we have the 99% accuracy. So the key limiter in this study is the high time cost. So simply training the model for 2000 epochs took somewhere around 331 minutes, and that's excluding the rest of the tuning of hyperparameters, so that will actually inflate the numbers even further. So with that said, let's move on to test 2. So in this case, there are 18 cases that are being used in this test. So we also included the testing set for 119 and 310. As you can see, we actually achieved 100% accuracy even for 310 and 119, which we did not have the testing data, and this will serve as a validation on the progress of the model itself. So in conclusion, the initial purpose of the study is to come up with a practical iris recognition system using convolutional network. So as the results presented, the system is fully capable in recognizing iris with very high accuracy. So out of the 40 classes that we have 39 classes that are perfectly recognized, and there's one with the lowest accuracy at 75%. So as a result, the purpose of the study is fulfilled, and the system has been proven to be fully capable to be applied at this point. Any further study should be focusing on further increasing the number of classes that the system could recognize. So in this case, at 40 classes, that number could be increased for in future research, as well as introducing some other iris features that will further make the model more robust. So that's all from us today. Thank you so much.